look at the pretty diagram. You know, I feel like this unit has been very sparse on diagrams compared to our last one. Not nearly as many pretty pictures. So much math, though. Alright, multi-step conversions with reactions. So multi, I know, means many. So this must be multiple step conversions without reactions. So I don't know what reactions are anyway, so I guess it's good that we're not doing them with reactions, right? The mole unit serves as a way to connect measurements of mass, volume, and amount. So these are all connected to moles. Okay, for example, chemists can easily convert from mass to volume or from volume to molecules by first converting to moles. So I guess second would be, I don't know, something else. These types of conversions, not conversations, take a little longer because they take multiple steps. So yeah, I was right about the many thing. However, as long as the chemist knows which steps they're doing, the equation can be set up successfully. So what's this figure say? So we got moles at the center. Moles in mass is molar mass. Well, okay, so from going from mass to moles or moles to mass, you use molar mass. Volume is 1 mole equals 22 more liters. Back and forth, you use this. So these are like this is like the conversion factor. And these boxes are like the actual unit, and then amount is particles, atoms, molecules, etc. 1 mole equals 6.02 times 10 to the 23rd whatevers. I guess whatever is like atoms, etc. molecules, stuff like that. So let's look at the examples. Alright, so it says if an 11.2 liter balloon at STP, so that means 1 mole equals 22.4 liters, explodes, how many particles of hydrogen burn? Well, I can go to moles, but I can't go straight to particles. So like the thing said, I'm going to go to moles first. In fact, let's look at this right here. We're starting with volume, right? This is volume. We're going to go to moles, and then we're going to go amount, which is particles. So if you look at the picture, we're basically, okay, what was it? Volume, moles, amount. We're basically going volume, right? We're going volume to moles, and then to amount. So we're just going whoop, whoop, like that. Alright, so what's this say here? So 11.2 liters. You know, we do the STP thing, liters cancels, we get 0.5 moles H2. And then I guess this basically goes over here, and you basically just do another one. So moles, now moles has to cancel. We want to get to particles, right? But hydrogen is H2, so it's a molecule. 6.2 times 10 to the 23rd molecules, right? That's this one right here. Right here, right? And so that's half. So half of that is 3.01 times 10 to the 23rd molecules. So two-step conversion. Okay, let's look at another one. Let's look at another one. How much would 1.2 times 10 to the 24th ionic particles of aluminum oxide weigh? So aluminum oxide. First you got to know aluminum oxide is Al2O3, which for review, if you don't, you got to figure out the charges. So aluminum is 3 positive, oxygen's 2 negative. Then you got to balance it. So you get Al2O3 when it's balanced. So we start with amount, because that's particles, and then we got to get to weigh, which would be mass. So now if you go up here, let's use a different color. You're starting with amount, and you got to go to mass, but you can't just go straight there. You can't do that. No. You have to go through moles. So you go to moles, and then you go from moles to mass. So that's number 2. Okay, so now first we go to moles, so we use Avogadro's number, right? Ionic particles cancels out. And then we we get moles, and moles goes back over here. Now we gotta go to mass, so we gotta find the molar mass, right, of aluminum. So molar mass, aluminum, there's 2 of them. Aluminum's 27 times 2 is 54. Then oxygen is 16 times 3, 58 plus, or 48 plus 54 is 102. So that's how they got that then. So there you go, 204 grams aluminum oxide. Okay, alright. Number 3. Whoa, there's 3 of them. How many atoms of chlorine, so now we're looking for atoms of chlorine, are in 79 grams of strontium chloride? So again, we got a strontium, okay, that's an alkaline earth metal, so it's +2. Chlorines, halogens, -1. There's got to be 2 of them. So that's the formula for strontium chloride. So we're starting with mass, and we're going to atoms. So here I would go mass, moles, and then atoms would be amounts. That'd be boom, boom, boom. What I'm noticing right here is they have 2 moles. I wonder why. That might become an observation that we need to talk about. So let's see if we can figure this out. So 79 grams, we go to moles. So this is moles of strontium chloride. So that's mole 1 is strontium chloride. And then 0.5 moles SrCl2. Now they're going to Cl. So there's, in 1 mole of SrCl2, there are 2 moles of Cl. So in half a mole of SrCl2, there's 1 mole of Cl. So this second mole is just pure Cl. And then we convert to atoms using Avogadro's number, and there you go. So this is the actual atoms of Cl, and this was the grams of SrCl2. Make some observations, be ready to discuss. This is interesting. I like this. It's exciting.